In this video, our goal is to learn how to calculate the sample size required to estimate the population mean. In an earlier video, we learned about how to calculate the sample size when we're trying to estimate the population proportion. In this particular example, for the sake of emphasis, we're trying to estimate the population mean, and we do not know what number of sampling units to take. The correct formula to use is n equals z of alpha over 2 multiplied by the sample standard deviation divided by the margin of error. Always note that after this calculation, if you get a decimal value, you must always round up to the nearest whole number, regardless of the size of the number after the decimal point. So we take an example. People were polled on how many books they read the previous year. Initial survey results indicate that there is a sample standard deviation of 19.7 books. Based on this information, complete parts A through D below. Question A. How many subjects are needed to estimate the mean number of books read the previous year within 6 books with 95% confidence interval? Take note, the goal is to estimate the mean, and in the process, we would like to know how many subjects or the sample size. So using the provided formula, n equals z of alpha over 2 multiplied by s all over e all square. Please do not forget the square. To use this formula, we need a couple of pieces. We need z of alpha over 2, we need the sample standard deviation, we need the margin of error. First, to get z of alpha over 2, well, I will draw my normal distribution in this case, and I will locate my confidence, my level of confidence, 0.95. And so I need my z value. Going back to StatCrunch, I need to go to calculators, statistics calculators, go to the normal distribution, and I'm going to drag this over and a little bit of zip and zap here. So I want between, and the size of what is between is 0.95, the confidence level, compute. The positive value, 1.96, is what I want. So you have 1.96 here. Then what about S? We were given S earlier. S is 19.7 books. And the margin of error, E, is equal to, we're to have this within 6 books. This is 6. So we can plug everything in. So N is equal to 1.96, which is our Z. Then S is 19.7, and our E is 6 all square. This will be equal to approximately 41.41351,511. So rounding up, that'll be approximately 42 subjects. Question B. How many subjects are needed to estimate the mean number of books read per year within 3 books with 95% confidence interval? The only information that has changed is from 6 to 3. So using the same formula, we have n. I'm going to adapt this same piece back here. And the only piece I will change is the 6. I'll change it to within 3, all square. So this will give us approximately 165.65400604. That'll be approximately 166 subjects are needed. Then, question C. What effect does doubling the required accuracy have on the sample size? What you might observe is that in answering this question, by doubling the accuracy, that means going from an error of 6 points away to an error of 3 points away, The effect it has on the sample size is that if you consider 166 divided by 42, this will give approximately 3.95, which can be rounded up to 4. So in essence, doubling the required accuracy nearly quadruples, nearly halves the sample size. So in this case, it stands to reason that based on this observation, doubling the required accuracy from 6 points off to 3 points off nearly quadruples the sample size, or nearly multiplies the sample size by a factor of 4. Then question D, how many subjects are needed to estimate the mean number of books read the previous year within 6 books with 99% confidence interval? So compare this result to part A. How does increasing the level of confidence in the estimate affect the sample size? Why is this reasonable? To solve this question, we use the formula we used earlier, which is used in part A. In part A, we use the formula Z of alpha over 2 multiplied by S all over E all squared. To find our Z of alpha over 2, we went to StatCrunch. This time, we want within 99%. So I'm going to go to StatCrunch, and I'm going to change this to 99 and compute. This is 2.575 approximately. So I take that 2.575, and then my S is from part A, 19.7, and my error is within 6. So N is equal to 2.575 multiplied by 19.7 divided by 6 all squared. That will be approximately equal to 71.479999997. That will be rounded up to 72 subjects. So what do we observe if we compare the result here to the result in part A, where we had 42 subjects? We observe immediately that as the confidence level increases from 95% to 99%, there is an increase in the number of subjects. So it goes without saying that for a fixed margin of error, that is error equals 6 and error equals 6 in part A and part C, greater confidence can be achieved with a larger sample size. With that, we proceed to the last question here in this chapter. With the high cost of fuel and intense competition, the major airline companies have had a very difficult time financially in recent years. Many carriers are now charging for checked bags. One carrier is considering charging a 2-tiered rate based on the weight of the checked bags. Before deciding at what rate to increase the charge, the airline wants to estimate the mean weight per bag checked by passengers. It wants the estimate to be within plus or minus 0.25 pounds of the true population mean. A pilot sample of bags checked gives the following sample data. Question A, what size sample should the airline use if it wants to have a 95% confidence? Well, in this case, we are trying to find the size of the sample to be used when we are trying to estimate the population mean. This means that the correct formula to use is what we established earlier, which is N equals the critical value multiplied by the sample standard deviation divided by the margin of error all squared. To get our Z of alpha over 2, in this case, this is the 95% confidence interval, which we got earlier to be 1.96. And then S, in this case, will be the sample standard deviation. So we have to find the sample standard deviation of this data set. You are more than welcome to type this data into StatCrunch and compute the standard deviation. You will get 3.791 approximately. And then with that, we need the margin of error. The margin of error, E, was given as 0.25 pounds. So we have every ingredient we need. So we're good to use the formula. Using the formula, N is equal to 1.96 multiplied by S, which is 3.791, divided by the margin of error, which is 0.25. And after that, we're going to square the answer we get. This will be approximately equal to 29.72 and so on. And that rounds it up to about, and before I round that up, I want to remember to square this. Yes, this gets me a lot. I will confess you want to square that answer. So it's 29.72144 all square. That gives us about 883.3639957. So if we round this up, we get about 884. This is the sample size that should be used. Well, question B. Suppose the airline managers do not want to take as large a sample as the one you just determined in part A. Of course, that's a lot of work, trying to weigh 884 bags. What general options do they have to lower the required sample size? One, they can reduce the confidence level from 95% to probably 92 or 90%. So they can reduce the confidence level. Then another one is increase the margin of error. Again, they can increase the margin of error beyond 0.25 pounds. And then one other way is to combine both actions above. That is, reduce the confidence level and increase the margin of error beyond 0.25 pounds at the same time. So combine both actions above. With that, we come to the end of our discussion on confidence intervals.